Hi, this is Mr. Manley. This is an introduction to matrices. A matrix is an array of numbers that is represented in a rectangular form. This one that we're looking at here, I'd call that a square form, and a square is a rectangle, right? We would take a look at another one here and see that's a rectangle. Also, I'm going to say that this is a matrix that is in a dimension of 3 by 2. Because matrices, their dimensions, these are the dimensions, are identified as rows by columns. Kind of like a length times width measurement, but this is row by column. So notice that this is 3 rows, 1, 2, 3, and 2 columns, 1, 2. If we go back to the original page here, this is a 2 by 2. Matrix operations initially are very intuitive. Exactly what you think they would be. If this is matrix C, this is matrix C here, and I want to know what is 2C, it's exactly what you think it would be. 2C is equal to, and I just multiply everything by 2. And I got matrix 2C. Here's matrix addition. Matrix addition would be exactly what you think it would be. Here, I'm going to add each element. 4 plus -4 is 0. -1 plus 4 is 3. 6 plus 6, 12. -6 plus 1, -5. So matrix addition is exactly what you think it would be. Here we have a combination of multiplication and addition. I'm going to take this first matrix C, and I'm being asked for 5C. So let's do that. Multiply each element by 5. And then the second one here, 3D, is asking us to multiply each of these elements by 3. And we add them. Just saying, add those two matrices. Just like we did in the previous addition problem, we add each of the elements. 30 plus -21, 9. 5 plus 15, 20. Now here we're going to get into matrix multiplication. I'm going to find out what is C times D. And this is not intuitive. So you might look at this and say C times D is going to be 3 times 0 is 0. 1 times -3 is -3, -1 times 2 is -2, and -2 times 2 is -4. But this is not correct. That's not how matrix multiplication works. And you might say, well, why doesn't it work that way? The context of a matrix, what matrices are used for and where they come from and what they mean, makes this calculation meaningless. You won't be able to get some sense for that until we get further down the line. But for right now, I'm just going to show you how to do it. And can definitely be a process that trips students up. So you really want to pay attention, take good notes, and then if you need to, pause, re-watch, and see if you can follow the process here. And I'll do 2. I'll do C times D, and I'll do D times C. Because matrix multiplication, as it turns out, is not commutative. C times D is different than D times C. So, first off, it's probably good to look at what the resulting dimensions are. So I'm going to say that a 2 by 2 matrix times a 2 by 2 is going to give me a 2 by 2. So I got that, 2 by 2. I'm also going to label each of these by its row and column. So this one here, this position here, I'm going to call position 1, 1, row 1, column 1. This one I'm going to call position 1, 2. This is position 2, 1, second row, first column. And this is 2, 2, second row, second column. So I've got this like partitioned off here into this group, this, and this, and we want to fill each of those in. Maybe I want to put those labels in a less conspicuous place, like 1, 1, 1, 2, 2, 1, 2, 2. So how do I fill the first box? Well, it's the first row, first column box. And here's how I do first row, first column. I go first row, first column. So I use the first row of C and I use the first column of D. And then look at how I use them. I'm going to do 3 times 0 plus 1 times 2. Need a little space here. I just need a lot of space for this whole thing, right? Let me go ahead and give myself a lot more space. Okay, so remember that's 1, 1, 1, 2, 2, 1, 2, 2. All right, so this is 3 times 0 plus 0, or not 0, plus 1 times 2. All right, so do you see how that worked? I went the first number times the first number, the second number times the second number. So just stop and look at that. I mean, yes, it's confusing. It's not what you'd expect. But you just got to slow down and look at it. And now see if you can predict what this next one is going to look like. This is up here. Look at the 1, 2. What does that mean? That means row 1, column 2. That's what the 1 and the 2 mean. Okay. So that's row 1, column 2. All right. 3 times negative 3 plus 1 times 2. So with the first number, second number, second number. Row, column. So I always use the row of the first matrix, and I always use the column of the second matrix. And that never changes. Okay. Now down here. Row 2, column 1. So it's row 2, column 1. Negative 1 times 0 plus negative 2 times 2. See it? Really stop and see if you can predict. What am I going to plug into this space here? Row 2, column 2. Row 2, column 2. Okay, so that's going to be negative 1 times negative 3 plus negative 2 times 2. And from there we just have some basic arithmetic. It's going to be 0 plus 2 is 2. Negative 9 plus 2 is negative 7. 0 plus negative 4 is negative 4. 3 plus negative 4 is negative 1. Now, if you really want to check that you're following this, you might go on and look, all right, could you do DC without any instruction at this point? I'm going to go ahead and set it up. Hopefully I have enough space here. It's going to be the same 2 by 2. This one. Okay, I'm not going to make so much notation on this one. I'm just going to go right into it. D times C. It's going to be first row times the first column. So that'll be 0 times 3 plus negative 3 times negative 1. Then I'm going to do first row, second column. 0 times 1 plus negative 3 times negative 2. Then we're going to go second row, first column, 2 times 3 plus 2 times negative 1. And finally, the second row, second column, which will be 2 times 1 plus 2 times negative 2. And simple arithmetic. 0 plus 3 is 3. 0 plus 6. 6 minus 2. And 2 minus 4. 2 minus 4, negative 2. And we see that we did in fact get two different results. I said several minutes ago that matrix multiplication is not commutative. C times D is not the same as D times C. So that's an introduction to matrices and an introduction to matrix multiplication. And like I say, I know it's not intuitive at all. It doesn't work the way that you think it would work. But you've got this step-by-step process here. And if you're not understanding or you're not following the process, you have two samples here and you can compare one to the other and get the pattern. And everybody can learn how to do it, how to do matrix multiplication.